Alright, I have a Douyin Baker convection oven that's not getting hot enough. So this beast here, it's the bottom right hand oven that's not getting hot enough for them. So I'm just going to fire up the unit here. Blower motor's running, I'm just doing the basic checks. Temperature's going up, so the burner is on. I'm just going to hit fast forward here, just because it takes a little bit of time for this thing to heat up. Alright, so the blower motor just shut off. Anytime that shuts off, the burner's going to shut off as well. So every few minutes, that blower will change rotations. The reasons for that is we want even heat distribution, so we don't want just the right hand side of the oven, all that product to get the heat. It has to go to the other side. So you'll actually see this happen in combi ovens as well. It's pretty important in the baking equipment. It just makes for even cooking, even heating. Alright, so blower just turned back on, burner's back on, temperature's going up. So far so good. Just gonna hit the fast forward one more time here. Alright, so listen carefully here. Burner just shut off. Blower is still running. So we have found our issue here. This burner should be running right now. We're still calling for heat. Alright, so to access all the burner components and all the module and everything, it's in the back of the unit. So that's a little bit challenging on this setup here. So I'm going to pull out this unit, which I can't pull out all the way because the water line's too short. So I'm going to jimmy my way in there. Disconnect that, pull that oven out. Now the unit I'm working on also has a soft copper pipe installed, so I can't pull it out. Probably should have put a 3/8 flex line compression on there so you could pull the unit out, because now you can't really test for steam. But that's another problem for another day. Okay, I'm going to rip this back panel off. Okay, and it's going to expose all the components I need to test, and I'm going to go through the sequence of operations. Alright, so my goal is to get to this ignition module here. So I'm just going to map out the sequence really quickly. So if we follow here, we have our transformer. Okay, our transformer is being fed all the way up here to our incoming power. So it does go all the way up. I'm not going to draw it, but the incoming power is all the way here. That's your L2. Okay. And then the second side of the circuit, which is my L1 side, is coming through here. Okay, so here's what our sequence is. So I'm going to draw it coming in. So we come off our L1. We have a little 2 amp fuse breaker switch. Then we have our switch here. And then once our come through our switch, we come here. And then we come to our high limit right here. High limit closes, it sends power to our pressure switch. Okay, our pressure switch here is connected to this motor. So if this motor's running, this switch right here should be closed. From there we feed pin 4 on this R4 relay. The contacts are normally open. Okay, what closes the contacts is this coil here, which basically goes back to the board. That's your call for heat. Okay, once our transformer's hot, we get our 24 volts to our module. Okay, once we have our 24 volts to our module, we're going to start our spark sequence and flame detection. And if we have good flame detection, 24 volts will stay on the gas valve terminals for the module, and we will get our power to our gas valve, and that would be completing the circuit. Alright, so I'm going to draw my attention to this section right here, okay, based on this intermittent issue. So one of two things are happening, okay. Either I have 24 volts here constantly, okay. If I have 24 volts here constantly, but I'm not getting voltage here, that means the module's in lockout, okay. We have not detected the flame. Okay, if I do not have voltage here, I'm going to work upstream. Okay, I'm going to work backwards and try to figure out what happens. Okay, how this module resets. How this module resets is you have to lose power to the module. Once this module loses power, okay, it will reset and it will try for ignition. So every couple minutes, this motor will stop running and it'll change rotations. As soon as that happens, okay, this pressure switch opens. Once this pressure switch is open, okay, we have now lost our 24 volts to this module. Once that pressure switch opens, we have now lost power to our transformer. Once you lose power to your transformer, okay, you no longer have voltage going to the module, and that's how it resets. So every couple minutes, this module resets from the blower motor going in the opposite direction. Alright, so I'm testing power into my module. I have 21 volts. The burner is running. My blower is running. So I just need to be patient here, wait for the intermittent problem. Alright, my blower just changed directions. My burner did not fire up. I have 0 volts at the module. Alright, I do not have voltage here at my module. So what I'm going to do is work backwards, okay? Because it's an intermittent problem, I have to work very quickly, okay? So these are the steps I'm going to take. Okay, I'm going to come and test the incoming power to this transformer, okay? So the primary side. If there's no power here, I'm going to work backwards. Alright, I'm testing the primary side of the transformer. I have 0 volts there. Okay, so the next point here is this relay. This relay is really hard to access, okay? So I'm not going to test this relay. I'm just going to go to the next thing in line. So the next thing in line is this pressure switch. So I'm going to test the outlet and the inlet of the pressure switch, okay? And I'm going to test it to my L2 right here, okay? Blue to red. I don't want to test red to red, right? Because this line here is red. It's very important that you know which line you're testing to. You don't want to test L1 to here, because then you're going to get potential difference. Okay, so I'm going to test here. If I get 0 volts, I'm going to test here. If I get 0 volts, I'm going to keep working backwards. My next test point now will be that same L2 on the blue line to the thermostat outlet and inlet. If I get 208 right here on the inlet, I know to stop troubleshooting, okay? If I don't, I'm going to keep working backwards, and this comes all the way back up to our switch all the way here, okay? So like I said, because it's an intermittent problem, I have to troubleshoot super quickly, because I've had it where, just say I'm start troubleshooting and 30 seconds later, it starts running again. Whatever switch is open has closed, okay? Alright, so I'm testing from L2 to the outlet of the pressure switch, 0 volts. L2 to inlet of the pressure switch, 0 volts. Next I'm going L2 to the inlet of my thermostat. I'm getting 208 from L2 to the inlet of the thermostat. Next, I'm going to test L2 to the outlet of the thermostat. I'm getting 0 volts there. So we've lost our voltage here at the thermostat. So I'm going to test across it to confirm. We're going to test potential difference here. My blower motor is running. And we have 202 across, which tells me this thermostat high limit is in the open position. Alright, so let's draw our lines here. I'm not going to draw this one all the way up. You know that's going right up to incoming power. That L2 is good. So now if we check our power, okay, we did not have power here. We could not test this point, okay? We did not have power here. We did not have power here. We did not have power here. We did have power here. So what does that mean? That means we can draw our line right through. Okay? I have power right at this point here. Okay? I do not have power at the outlet on this test point. I can't see that too well. I do not have power on this side of the switch. Okay? So what does that mean about this high limit thermostat? It means it's in the open position. Okay? So anytime I have something in the open position, I always test across. So whenever testing across, first thing you have to do, confirm there's voltage coming in. I confirmed that. How we confirmed that, we went from there to L2. So when I tested to that point right there, I had 208. Okay, that test was done. From this test point here to my blue side of the circuit, which is my L2 right here. Okay, so I've tested from inlet to here. Now when I tested the outlet, I was getting 0 volts. And then the last test I did was test across these 2 points right here. Okay, so when I came and tested across these 2 points, now I'm testing red line to red line, potential difference, no longer going red to blue. Okay, so when we do that, it's potential difference. We're subtracting. Okay, so I got 208 volts in, 0 volts out. That's going to give me 208 volts across, which tells me this switch is in the open position. Alright, so I'm just going to change this high limit. It's pretty straightforward. Couple screws, take the wires off, move the insulation. You can see there where the probe's mounted. It's on the back of the oven cavity wall. So I've got the new one mounted. Now the old one had silicone on the leads. You no longer have to put silicone on there. I did confirm with the manufacturer. Alright, so I'm just going to fire up the oven here. Alright, it's heating up. I'm just going to hit fast forward here. And we just want to make sure we hit our set point. So temperature's off by about 20 degrees. I'm going to move the probe closer to where the sensing bulb is. And let's see how much closer we can get if we need any adjustment or calibration. So we're cycling off. So you can see we're at about 353. And the screen's showing about 350. We're off by 3 degrees. 3-4 degrees. I'm good with that. We're within the range. Alright, just to give some background info on this. This is a new site. It was the first service call I had at the site. They've been having this intermittent issue for a while. So when I looked at the parts, the flame sensor looked new, the module looked new. So most likely those parts were changed. Those are the most common parts to change when you have an intermittent problem like this. In this case though, you could see around 270 was cutting out. So what I had done is I probably read that schematic for 3 or 4 minutes. Doyon did a really good job of breaking down the schematic and simplifying it. I didn't have a service manual, but because the schematic was written so well, it was pretty easy to figure out what the sequence was. And based on that, we found the high limit was open. So the point I've been trying to drive home is don't be a part changer, be a troubleshooter, take your time, read the schematics, get to know the equipment.